In this module, we shall look at the performance evaluation techniques which determine the type of simulation which must be performed. Performance evaluation is the process of determining the goodness or the advantage that could be taken out of a simulation or an implementation. So if you look at a simulation is nothing but a behavior that mimics the interconnected systems and processes. So simulation of an aircraft, for example, Microsoft Flight Simulator, the simulation of an equation, say in MATLAB, are quite different in their scope. So if we look at the performance evaluation of these two simulations, we will have to define the model which determines the goodness of the simulation. The evaluation involves the measurement of an overall systemic behavior of a system. So the evaluation by looking at the kind of simulation has to be both efficient and certain. For example, if we just look at the two examples which I gave, Microsoft Flight Simulator is meant for people who are interested in enjoying the pleasure of simulation of an aircraft, whereas MATLAB is a serious work that involves a technical evaluation of a system using mathematical modeling. So if we look at both of these, the performance evaluation techniques have to be classified according to the simulation environment. The performance evaluation involves direct measurement. Direct measurement actually means that if a system is broken down into its constituents, each of the constituent is accessible and it gives output that can further be used for analysis. So the direct measurements as such cannot be abstracted. The beauty of direct measurements is that a system is put to test, workload is passed or injected into the system, and every constituent of the system gives measurements. The direct measurements are closest reality of the real world phenomenon. However, direct measurements as performance evaluation are not always possible. For example, if we look at direct measurement scenario, it needs a system to be in fully operational mode. For example, looking back at our scenario of one-hop communication network, we need direct measurements at the application layer for the number of packets which are being created by the sending computer side, the packets which are successfully being received on the receiving computer side, the packets which are being sent and discarded on the sending communication channel, that is from the wireless computer to the access point, and the packets which are being received by the receiving computer from the access point, the number of packets which are dropped and the number of packets successfully delivered. So direct measurement involves considerable effort and access to not only the outside but also within the system. Direct measurements are so sensitive to the kind of behavior that is exhibited by the real world system. Here, if we want to really determine the performance of a system, we must inject what if scenarios and different situations so that the system behaves differently and the measurements are able to capture the behavioral changes. So in all, direct measurements for a real world system are almost impossible to realize. If you want to classify the performance evaluation techniques, as we shortly discussed, in the real world, direct measurements provide good insight to the real world system, but lack the coverage and the comprehensiveness. So what do? As you can see, here we have direct measurement and modeling. So it means modeling can be considered as an almost alternative to the direct measurement. The direct measurement gives us results which are either analytical or could be simulated. Now, if you look at the virtual world, which is an approximation of the real world, direct measurements are not possible for the virtual world if we just want to realize the virtual world through an analytical model. But direct measurements are possible if we simulate the virtual world. The simulations actually give us a possibility of creating a virtual world of the real world, and we do the simulations as a means to perform direct measurements. The types of simulations that we are considering for the scope of this subject only fall in the world or in the paradigm of the virtual world. Here, as we can see, there are different kinds of simulations that we may come across in due course of time. We have Monte Carlo simulation, trace-driven simulation, the discrete and continuous event simulation. So, what is Monte Carlo simulation? Monte Carlo simulations involve situations in which the overall behavior of the system is not dependent upon time, but it may be dependent on another factor. For example, a spatially or a phenomenon that changes its behavior according to the space phenomenon. It involves probability that changes with due course of space or with any other parameter. The trace-driven simulations are actually an ordered list of events which serve as inputs. Since it's an ordered list of inputs, so we expect an ordered list of outputs. It is interesting to note that the level of probability and likelihood both in Monte Carlo and trace-driven simulations depends upon the distributions and the randomness that we inject into the system. The continuous events actually form the states which change according to the inputs at virtually any non-discrete event. So it means the events could be varying with respect to a continuum of time. So if we have a continuum of time, we would find a very large number of outputs and state changes. Since a large log and record keeping is required, so we generally transform a continuous event simulation into a discrete event simulation. An example is water coming out of a tap. The water coming out of a tap is actually a continuous event. Now, if we want to look at it as a discrete event, we'll have to consider the water flow every second or whenever a clock tick occurs. So the discrete events actually result into finite outputs.